All right, today what we're going to talk about is comparing linear and exponential functions. So let's go ahead and let's review both of them. So for your linear functions, that's your y equals mx plus b, or f of x. Ooh, that was a horrible y. Okay, there we go. Y equals mx plus b, or f of x equals mx plus b. B is your y-intercept, that's your starting value. M is your rate, or your slope. And if m is positive for growth, negative for decay. All right, so if growth or decay involves increasing or decreasing by a fixed number, which is your common difference, that's a linear function. Now for exponential functions, that's where you have y equals a times b to the x power, or f of x times a times b to the x power. So in this case, a is your starting value, or your y-intercept. So y-intercept, y-intercept. B is your growth factor, so that's your rate. And then here, if b is going to grow if it's greater than 1, and if it's between 1 and 0, it's going to decay. All right. And then here, if the growth or decay is expressed using multiplication, like doubling, halving, we use exponential function. So go ahead, make sure you write this part down. Linear and exponential functions share many characteristics, which we have already talked about. This is because they're based on two different but similar set of principles. So linear is where you're adding the same amount, that's your slope. And exponentials are where you're multiplying the same amount, which is your growth factor. All right, so let's go ahead and let's get started determining if this is linear or exponential. So we know right now our y-intercept is 0 to 100, but now we need to figure out the pattern. What are we multiplying or adding to get from one to the next? So we can go here, if we were to add or subtract, I'm going to do a different color. If I were to go here, that'd be minus 150. Well, that's okay, but that is not minus 150. So we know it's not linear. So now that we know it's not linear, now let's look at exponential. So remember, to get this rate, you have to take this term over the previous term. So 50 over 200, which gives you 1/4, or 0.25. So that checks out. Every time we multiply by 0.25, we get the next number. So this is exponential. Now, to write your equation, we take our y-intercept, which is 200. This is your a value. Our b value is your growth, and then you have x as an exponent. All right, now this one, we want to know what's happening. So does this table represent linear or exponential? So let's check. So now if I go from here to here, I'm subtracting 150 each time. So that pattern right now is going to make it linear. Oops. For here. All right, so now we just need to write an equation. So let's go through. My y-intercept is right here, and that is where this is. Our growth, or excuse me, not our growth factor, but our slope is 150. So that's right here. And we know that because that's what's being multiplied. And so you can go ahead and you can put it together this way, or you can write it this way. All right, now for this part, Marcus has $10 in his savings account, and he's planning to double his amount saved each week. So does this represent linear or exponential? Well, because we're doubling, we know this is going to be exponential. So for that, you can circle that. And now we're going to write an equation. So remember that 10 is the savings, and that's going to be your a value. And we said double means 2, And so that's your equation. And on this one, it says a company charges a one-time fee of $50, so that's your y-intercept, and plus $10 per day. So each day you're adding $10. So that makes it linear. So when you have linear, you're going to go through and you're going to look at the information you have. We start with 50 and we know that our slope is 10 per day. So you could write it this way or you could write it this way. That's fine. All right. And on this, the bottom ones on this page, it says the following 2 points are decaying exponentially. So it's telling you right away what it's doing. So what I do is I take these and I like to make a table. You don't have to make a table, but you can to help keep you organized. But I said 0, 500, and then 1 and 440. Now, since we already know it's exponential, we got to find the rate by taking this guy and putting it on the previous. So 440 divided by 500 equals 0.88 or 88 hundredths. So let's go ahead, let's put it all together. Now I know my y-intercept is going to be 500. And I know that my growth or my rate is going to be 0.88 because that's what we found here. And then we just put it to the x power. All right, and then on this one, this is just a reminder from what we've done before. So a couple things, you can find slope using the formula, making a table, whatever happens. So if you want to take a table, you can make a table or you can do the formula. Either way works. And now that we've got that, you're just plugging in your x and your y. Remember, you're going to take your x's and subtract them. And you're going to take your y's. And remember, since we started with 440, we have to start with 1. And then you're going to subtract that from 0. And you're going to end up getting negative 60 as your slope. And again, we know that we started, our y-intercept is 500. And we know that our slope is negative 60, excuse me. And now we're just putting it together. All right, now on this page, I'm going to do the first one for you, and then you're going to finish the other ones. And then so that way we can go and show you some other things. So it says, consider the linear function of f of x is 20x plus 5, and the exponential function g of x equals 5 times 2 to the x power. At what x value will g of x exceed f of x? So we basically were looking for when will g of x become bigger than f of x. So all I did is for your x values, I just labeled them and then continued all the way to 7. And then for f of x, I wrote f of x here. And for f of x, you're adding 20 each day. So if I start at 5 for f of x, I'm starting at 5, and I'm going to add 20. I'm going to get to 25, add another 20, get to 45, and then I'm going to continue the pattern all the way down. All right, so that would be all of f of x. Now let's look at g of x. G of x gave us the formula, and I know my y-intercept is also 5, but this time I'm going to multiply by 2. And then go ahead and complete the table by multiplying the term by 2 to get the next term. So the final part says, when will g become greater than f of x? So right now, not quite, here is when g of x is going to become bigger than that. So your x value would be 5. All right, so what I did for you on this problem is I already set up the equation for you. So you're going to complete this table by starting at 142, and you're going to add 5 each time. And at this table, you're going to start at 2 and you're going to multiply by 3. So go ahead, finish the patterns, and then it says at what x value will g of x be equal to f of x. So that's what you're looking for. All right, so go ahead, it's your turn to try this one. And then I also want you to do the same thing here. I set up the table for you. So you're going to go through, you're going to complete this part. And then for f of x, that's all of these. You're going to complete those values. And g of x, you're going to complete those values. And remember, no major calculator other than if you need to multiply or add something, but you just make sure you're careful with your numbers. All right, now let's go down here. It says find the distance between the y-intercepts of f of x is 12x plus 20 and g of x, which is this table. So this right here, this is linear because it's y equals mx plus b, and g of x is actually, let's see where it has space. Oh, and g of x is actually exponential. I'll just write it over here. So I know it's exponential because you're multiplying every single time by 0.75. So this would be your pattern here. So I started that, and if you look, whoops, where am I? Now to get, there is no y-intercept on here. So we don't know where the y-intercept is. So what I actually did was I extended the table this way, and I made 0 here. And if we're multiplying by 0.75 this way, we're going to divide by 0.75 going this way. So I'm going to take 16 divided by 0.75, and I got 21.3. So 21.3 is your y-intercept. And that's where I got this y-intercept. And then we have 20 from up here, and then subtract them, you get 1.3. So it's just finding the information from both. All right, so I want you to go ahead and I want you to try this one. And then let's look here. On this next one, you are to do the table, and I already filled out the information for you. So it says, given the equation in the table, what's the y-intercept of f of x? F of x is 9. The y-intercept of g of x, well, we don't have it here, so we have to go backwards by subtracting. So if we added this way, we got to subtract this way. And we know we're adding or subtracting because it's the same amount each time. All right, so our y-intercept for g of x is 14.5. What is f of 3? So remember, it's telling us x equals 3. So we're going to look here, and we're going to go 9 times 2 to the third power because this was x. So we're going to write 3 in instead. You're going to get 72. Now for g of 3, well, this is 3 here, so wherever you see x, we're going to figure out where is g of 3, which is 22. And then now we're going to add the 2 together. 72 plus 22 gives you 94. And then it says here, y-intercept there, and do the sum of the intercepts. So you're taking this y-intercept, and you're going to get that y-intercept. So it's just using all the information that we've known. All right, now we're going to talk about regression. So I'm just going to give you this first one and show you the examples, but we've already done linear and exponential regression on Desmos. And so it's just making sure you plug in your points, and then linear regression, the correlation coefficient, that's your R value. Then you have an exponential regression, and then that also has an R value. And then it says which one's the best model. That means which one is the R closer to 1. So this is new in the fact of new information. Because if you look here and you look here, linear is closer to 1 than exponential. So this one, linear, would be the best model. And then using the prediction, predict the exam grade of someone who studied for 6 hours. So wherever you see X, you're going to plug in 6 instead. So just as a reminder, and here's some of the work, but you can type this in. When you type in your points on Desmos, make sure you go, there's a little line with some points up here. Click on that and you're going to do linear regression. And this is where we got our equation and we got our R value. And if you look, those points are pretty close to the line. And then let's compare it to the quadratic. Again, same points, but this time we're doing exponential regression. And we've got our equation and we've got, oops, where'd our R value go? And then, so we've got that. And then if you notice, you got your points here too. So when we go that, apparently my R value didn't show up. So I'll just have to make sure I double check that, but that's what you would get there. Okay. All right. So what you're going to do is you're going to get on Desmos and you're going to do that, entering these, and then make sure you're looking at linear and exponential, and then which one is the best mode. So remember, you want closer to 1 or closest to 1. Wow. So you want your R value closest to 1. So which R value is closest to 1? And then that's going to do that. And then you're going to answer the question using the correct model. All right. And then that is comparing linear and exponential functions.